This is the visualization. So the main screen. Let's start by the main screen. This is the main screen, but of course it's up to you to make your own design. But this showing almost the most important thing. Here you have the kilowatt hours for any screen in the EAF control room. You need 200 kilowatt hours anyway. Power on, power off, tap to tap. And this is the furnace switch, the vacuum switch, the reactor, and the transformer. Then you have the selected curve and the basket here. So this is process function. So you have here the megawatts, MVAR, and power factor. But this is possible to configure it. You can change it. In the menu you can change it. The amps, and here this is the selected let's say regulator parameter that can be the arc resistance, the impedance, whatever. And so this display not here of course, but the set point is displayed as a small bar, and you can see the bar graph moving up and down on the set point itself. And here, this is the regulator information status. You have here which kind of mode are you, if you have ignition, short circuit, manual. Here the controller mode if you are, let's say, under regulator or not. This is we can cancel. This is not interesting. And this is the non-conductive body counter, because somewhere you have to touchdown counter.
Non-conductive.
Non-conductive.
This.
Non-conductive. S, I don't know why they put S there. Or touchdown counter. Okay. Then you have here, when you press on the menu, you have a menu here, where you can have all the access to all the pages. Yeah. But again, yeah, you may decide for another design. Yeah? So then you have the. This is interesting diagram because visualization, because there you see exactly how the regulator is working. You see the measurements, and you see the result of the calculation at each stage. And up to the valve. So here you have the set point table. So you see where here you see the set point which is selected in function of the transformer, reactor, and curve here. And here you have the overvoltage compensation, which is have its correction here. And here you let's say change again. You have this DISO. In this case, is DISO. In previous case, is ASO. This is the dynamic set point optimization, which is sending this coefficient. You see the result here, and then the final set point. The final set point is already here in the controller. Yeah? So this is the PI controller. Before you have all the measurements, the measurements are compared to the set point and you get into the controller. And then after the controller, this you can cancel this function, it's not useful anymore. And then you have the manual mode, and then you get into the ramps and final destination to the veins. Here this is the hydraulic, let's say, for the touchdown function, and here the loop for the short circuit. And when you click on this window, you have a pop-up sub-window on each one. Yeah, of course, I cannot show you here, but you will have for example, if you click on the point analog details, this is this one maybe? Yes. When you click on this window, you have all the details of the electrical calculations. Yeah? And if you click on this small, let's say, detail, you have a small scope to see the evolution of over 30 seconds of the parameter. I have no demo version, but I have another. The ancestor. Yeah. So you see, you can click, you have the details, not so many details here, or you may have more details. Here, this is the preparation, again, the calculations. And if you click here, so you have a small scope to see the evolution of the parameter. Of course, this is not very interesting, but here, more variations. This is helping to make the fine-tuning of the regulator and all these functions. Because it shouldn't be a black box. So if you click on the controller, you don't see so many things here. On the controller. You see on each function you have the possibility to have access. Okay?
Well, just if you show the Arcos, Arcos, just if you show us the pictures, monitoring. What's that? Is it different?
This is the ancestor. This is the ancestor of Fine Art. Arcos was my second regulator. Fine Art is the third.
I see.
And you're going to be the fourth.
What is the first name?
Eh?
What is the first name?
The fourth? It's up to you to decide. make new design or whatever, but that's it. This is the basic function I want to show you. Well, there is a deep test. If the deep test is described here, I guess I didn't describe the deep test in this document. No. So, this is to make the deep test in automatic. Yeah? Deep test, you put all three electrodes in the bath or all together or 2 by 2. Yeah? So, it's giving, let's say, I prefer to have the three-phase deep test because then you have only mutual.
Inductance. Mutual inductance.
Yeah. 2 by 2 has less interest. But you have still the possibility to select whatever you want. Yeah? And here, so on the display you have the voltage, the current, and the should be the power. Arc resistance we don't need. This is a mistake on the screen. And here you display all the measurements. Okay. So finally, there were two methods here. Either the regulator is doing it completely automatically. It means you press the button start and you lower down the electrodes and put it in the bath. And when the measurement is stabilized, it's finished. And here I decided not to do it automatically because for me it remains a little bit dangerous if you don't have the correct measurements. So it's done manually. That means the operator or myself are lowering the electrodes until the bath. And when the current is stabilized, I push the start button, and the calculator, or the PLC, starts to, let's say, accumulate and calculate the parameters here. And when it's finished, there is a stop available here. I click stop, and then the values are sent to here after calculation, where you get the average value for voltage, power, current power, impedance, and then reactance and resistance. So this is not described, but it's easy.
The purpose of deep test is to calculate and measure the short circuit reactance.
Yes. And resistance. And of course, don't forget that you have many parameters. So, for example, here is the transformer, because we need to put this transformer features inside. So you have the transformer, the ranges from transformer, the ranges for the measurements, the TPs and CTs, the calculation, the controller itself, and all these are parameters. you will get all this, let's say, overview. Huh? And the big test description here. Ah, in French.
French.
So I have to translate. Okay. Yeah. You have all the explanations here of the present visualization. Yeah? You are not obliged to do the same, yeah? But this will give you a base. Yeah? This will give you a base. Yeah?
It's useful for us.
Seeing that everything. This is the set point table. So here you have the reactor, and here the curve, and here each transformer tap, maximum 32. Yeah. So for each transformer tap, you can select here the regulation type, current, arc voltage, impedance, or arc resistance. And here you put the value, and here this is the megawatts for the dynamic set point optimization per phase. And here buttons to help you for the parameter input. Copy, paste, yeah. Otherwise, you get crazy by typing all this stuff. Because most of the curves, you don't need to tune at the beginning when you sell and put the furnace in operation. Then the people can tune themselves later. So you copy and paste. And you start with all, let's say, all table with values inside. That, for example, if you by accident you come to a situation where there's no set point, the regulator is crossing its arms and waiting for so everybody's asking, yeah, what's going on? The regulator doesn't work. Yes, it's working, but no set point. Standing.
No, also?
27. You're freezing or what?
Oh, right side one.
Huh?
Only right side.
Huh? It's okay, it was big room, eh?
It's cold.
What is it, money?
No, it's cold.
It's cold.
말한 사람은 좀 말하는 입장에서 좀
You ate hot paper yesterday too much.
Eh?
You ate hot pepper too much yesterday.
그러니까 지난 일은 얘기하지 마.
아 예.
So
왜 그래 안 하셔가지고.
hot pepper만 얘기했습니다.
Okay. So you will see the identification you will see later.
이거 진짜 많이
이 전기가 이거 컨트롤 이거 하는 PID는 기계도 다 안 들어나.
답변하죠. 아니 그러니까 이름만
이거 어차피 그림으로 표현하고.
다 직접 다 작성했을까?
This is the data scope. But this is done with WinCC. Yeah? So it's not very practical. In fact, you have to click on the button here to change the parameters. Yeah. Whereas with the Arcos it was better range where you have already pre-selected. You can pre-select the you have pre-selected the set of parameters. You see? Here. Okay, so there's nothing, but no. And here you can vary the time. Up to 1 minute by division. And here you could, we can select other parameters. For example, here there is nothing, so I select here something, basket energy, for example, and I put it here. Alright? Because better organized.
Purpose is for PA.
Yeah.
I could change the name to Siemens.
Now it's similar, but they are not normally the standard for Siemens is the Siemens PA is the Siemens. But I met the people from Vatron 2 weeks ago, and they are still allowed to sell it on their own. And if I have a customer, they can sell that.
Okay, but the purpose is first, and then change the name to the Gmail.
No,
Different.
totally different. That it was 2 different products.
Two different.
Yeah, totally different products. And they have improved the cement after cement bought the because at the beginning cement was not this big, it was very simple regulator. And for me, not very efficient. Because I've seen the cement it was in Saudi Arabia, 2001. Was not impressed.
Why
Because we had only one PI. Yeah,
Only one
for
PI.
all taps at that time. For all taps, you had one PI, and it was linear. That means you cannot break the proportional correction in case you have a strange rate. Yeah? So it was rather tricky to fine-tune the furnace. Customer wanted to have a cement, they had a cement.
하여튼 그래도 컨트롤 됐다는 거는 뭐
Purpose is bottom.
Yeah. The electronic
Electronic
vacuum.
bottom.
So this is the way you see, this is WinCC2, yeah? Nothing else. Screen, yeah? This is the typing mistake. It's nobody you can force, etc. You will see. It's not very interesting, but this is the mean value. This is very interesting. This is an interesting screen because whenever you change the set point, you want to see the results, and it's difficult to see on the screen where the measurements are changing every second. So on this screen you have the average value. Yeah. Oops. Shit. What did I do? Oh. What it is now? There it is. Yeah. And you have the possibility to reset. Because this is the mean basket. In case, because you have 2 reports here, you have the mean for the heat, or you have the average for the heat, and the basket. And when you are on the basket, we can reset. That means you start again from zero. So you make the change of the set point, you reset the mean value and you see the result. It is very useful. And you have all parameters, all calculated parameters. For most important is the current and the voltage and the active power. The rest is interesting but not so necessary. Deep test, we have seen. Mechanical tunes, we will forget for the time being. So these are all the digital signals which are exchanged with the furnace PLC. This is good to see whenever you have an alarm. And the meltdown program we'll see later. And data saving. Okay, in this version there's still PC for visualization, so you can save the values from the PLC down to the PC and upload the values from the PC to the PLC. Because when you switch off the PLC, there is no parameter anymore. Okay. And you have a button here to start with the Windows Explorer. To have access. This is the thing I don't like. This is the heat reports, or the measurement reports. And with the Arcos it was also critical. I mean, it's not very easy because all the heats are stored on one report. And this is one file. And what we need at the end, this is interesting, but at the end we need to have a table with all the hits you want in a month, in a week, or whatever. And you have to do it manually. So it's not very easy. So I had to develop myself the Excel sheet to open the hit reports and store it in an Excel sheet in proper calculation. So if you have ideas how to store, maybe, because installing a database on an electric regulator is maybe expensive for nothing.
I think it's just right to ask times maybe every day or week or months and so on. It's a bit follow the client request. They use the data to make some report and some analysis.
The reports.
어제 그 PI 담당하는 공부는 아침에 많이
안 했습니다.
어제 저는 what is last day we finished the PowerPoint request. So PI corruption recommendations is remaining. We skip this.
Not yet.
And before the
Yeah, because yeah. We will go back to the
we will give the HMI manual and the PLC relation manual.
which one manual?
You show the HMI
Yes.
manual.
And what is the next one?
The next one is the explanation of the same DB. Actually, that's simple.
It's too cold now, eh? Now it's too cold.
Yeah.
But not 28, yeah? Let's find a compromise.
하나 끄고 한 개는 한 26도 앞서 해놓거든. 뭐라는 맛이.
이거는 전체적으로 기본적으로 제작되어 있습니다. 띠리리.
아니 그냥 전화 왔어요.
왜 이것도 전화 올 때도